Hi everyone. Welcome to the third session of our outer space attention working group call. In the beginning of the call, we wanted to briefly kind of like just see where we are at and then like talk about the agenda for the call. So the last two calls, we basically went through this issue document the Epsilon team prepared, and specifically last time we talked a lot about the EC recover side of things as well, and now in that kind of in the process of discussing that, a lot of the questions around kind of how to deal with this new relationship between private keys and on-chain accounts, that there's no longer like a strict one-to-one relationship, how like basically can individual accounts deal with these different identities they have. These questions were like they're like supposed to be the main topic for today's call, but then also just to briefly kind of like maybe talk about that just for a minute or so in the beginning. Do you think it also makes sense to talk about some of these bigger picture questions that, I mean, like just before we started the official recording, like that started to come up about like how realistic is this change, what kind of which like layers of the stack will be most impacted, these kind of questions, or would you kind of prefer to focus on the actual kind of substantive discussion? And I guess maybe the question is, I don't know, first to Alex or something, just because you were in the process of talking a bit about these other aspects as well right now.
Well, I guess we also want to maybe get Mike on the call. He was reaching out on the Discord channel. He probably got the wrong link, and maybe Ansgar, again, you share the link with him.
All right, give me a second then, and I'll make sure he's on the call.
Yeah, but on the last call, we also agreed that this issue document, we can keep extending the issue document, just incrementally adding new points. And I added 1.1d, which is the main topic for today anyway. Should all personas be accessible for EOAs? And then so we use the term personas for basically the different addresses a private key can refer to. And then the other point, or like a bigger question we wanted to tackle today, is the transaction access lists and how they could interact with the translation map. More importantly, maybe to have some kind of a ephemeral translation map. And lastly, if we have time, whether we could have some kind of a translation map in which entries expire, just to keep the size of the map restricted.
Right. So, and with my canal on the call as well. So I guess we can just get started then, and start about like this what we were calling like personas, different personas for one private key kind of situation first.
Yeah, I don't fully remember where we stopped on that discussion last time. I guess we were in favor. Okay, yeah, I do remember some parts. So, so the personas, the first part of it, which seems to be simple, is for each private key, obviously we have a public key a address, which corresponds to any given epoch. And we also have the legacy, like the short address. And it seemed that, sorry, there's just some really bad honking outside. And it seemed that we were in favor of these EOAs be able to send transactions with each of those addresses. And is there any, I mean, since people had time to think about this, anybody came across any issue with that, or any comments on that?
I'd like to point out that, like, from a user experience standpoint, I don't think users know about or think about private keys at all in typical usage. Generally, people just have seed phrases that then generate a list of an infinitely large set of addresses that they control, and like beyond that. So it might be quite confusing for users if suddenly like that some of their addresses are like magically related to each other in some way, given that they've not had that experience before.
So I guess what you're saying is, for example, MetaMask, if this address space extension goes ahead, suddenly users would see more addresses, right? But they don't necessarily would need to know which of those relate to which private key or whatever. All they care about is that they see the addresses.
I think they do, because if I understand what Peter's getting at is if you derive your private key from an HD wallet, which comes from the mnemonic, those accounts can't be associated with each other unless you have the secret. And so when you have two accounts in MetaMask, they are two identities, and you can operate under them independently, and they cannot be associated. However, with multiple personas within one private key, they are very strongly linked. Like, this is still a you. And so A, persona is probably the wrong word here, because it's still just one person, one identity. And B, I do think it is important to let users know that they are not getting privacy from those addresses.
Yeah, my personal opinion is that we should just have, and I don't think this is actually an like protocol level issue, but I think like users and tools should be told that they should only, that each private key, when they store it, should come with an implicit epoch telling you whether it's a private key for a legacy account or a private key for an epoch 3 account or an epoch 4 or whatever. And they should just, that they shouldn't like reuse private keys. Just like if you have accounts on multiple blockchains, you should use a different private key everywhere for obvious security reasons. A similar concern should apply. And I suggest we just need to like define a different hierarchical deterministic path where for each epoch, so the keys just don't clash.
Yeah, but this is basically just a recommendation. And it's the same way a recommendation how the different chain, like the chain ID is incorporated into the path or not. Because initially the HD wallets didn't make the distinction. And they only started to do that maybe a year after like the ETC fork happened. In the same way, I guess this is like an educational issue that we want to ask. Sorry. So we want to ask the wallet providers to not at least provide the option for users to use the same private key for all of these like different epochs. But should we talk about like this UX side, or should we talk about the protocol side? Because it's one thing that the wallet providers do X, Y, and Z, but if we have the ability on the protocol, then somebody gonna do it anyway.
So I think that it's a solvable problem on the UX side. I tend to agree with Peter that we should give advice to wallets when this comes down the pipe. We should advise, this is what we recommend. If everybody does this, things will go smoothly. If people don't do this, things are going to go badly, etc. But I don't think we need to talk about it yet. I think it's a solvable problem that we should bring up, but we can do it later, is my opinion.
But on this like technical level, is it because the currently, at least the old transaction format doesn't have the from address encoded there. It just directly follows from the signature. Is it needed to be changed, anything there?
Yes, we will need at least one new transaction type with address space extension. So whenever that launches, we'll have a new transaction type. And I think the current plan is just to have one, which is just long addresses. And so you can send a long address transaction type, in which case you'll recover to that. If we go with this proposal with personas, then we'll probably need something else in that transaction to indicate which persona you're trying to work with.
And this is what point 1D in the document mentions. And the last time we discussed a bunch of different options, but one option is that you would just include the entire address, which might be just too big. But we could also just include like the version byte and the prefix. And then depending on the version, that prefix might be shorter or longer. And like version 0, which is the legacy, it would be just single byte. But I guess this is like an optimization question then.
Right. And medium term, of course, we would, if once we kind of talk about these things, like moving away from trying ECDSA, from trying UAs, these kind of topics, then medium term, we'll have to move to transaction types anyway, where you specify the address that you want to start at, and then give it some just arbitrary bytes that it uses for verification or something. So, of course, we can still go have like for the meantime have something more optimized to the specific ECDSA and then period kind of type. So we just have to kind of put the period number in there. But we could also just go ahead immediately and move to the specify the from address transaction type. Yeah, just to briefly like talk about the on the topic of like, do we have to make them accessible on the protocol side? And there, I think while you could potentially like have a conversation about it like in the queue context, just as extension, you have one short address and one long address where the period bytes kind of like still set to 0, possibly. Basically, there you can at least talk about, you could have that one transaction type that can only access the one, and the one transaction type that can only access the other. But given that, and again, I feel like we should separate them, but still at least have in mind that we are going to, really want to also do this, the address, like the state expiry on top of this. And so if we end up having multiple periods anyway, we can't have one transaction type per period. So like we'll have to have like ways to specify which one to use anyway. So I don't really see why that should not also be between legacy, like basically version 0 and version 1 addresses as well. So for me, it seems clear that you should be able to always access both. I think it's like what we also talked yesterday, last call about, which is a more complicated question, is should you also just somehow be able to kind of like directly send from the compressed address, which like intuition seems to clearly be no, because it's not an actual address, it's just a pointer. But we kind of talked about that last time as well, so that's a more complicated question. But just from like the short address and then the long address that both kind of like belong to the same private key, seems like they're really like we really have to allow sending transactions from both.
Yeah, the compressed one is the second question, but I just wanted to at least close the conversation on the easy part. Do you want to allow like sending from any of these addresses? And but the compressed one, I guess, is a different question. But did we?
Yeah, sorry.
Yeah, did we? There doesn't seem to be anyone seeing any issues so far with it, apart from like the UX issue on wallets or like privacy issues on wallets.
Right. And in a sense, I don't know, this is probably silly, but there's this weird failure case that could happen if you ever have a long address that for some reason reaches somewhere that it shouldn't and then gets kind of truncated or something. And like just, of course, kind of by accident, but also kind of like, of course, by design, you kind of end up with the short address that happens to correspond to the same private key in case it's just truncated, not actually compressed. So in a sense, maybe this is also somewhat of a fail-safe for at least for UAs, but ideally this should never happen. Just saying though, it could happen.
Something to add to the list for after we talk about compressed addresses. What about contracts? Can contracts execute from different personas?
Wait, so like the situation, right, is that even for accounts, you basically have one private key and then multiple accounts, and those are just distinct accounts on chain. Whereas for contracts, because you don't have private keys that control them in the first place, each contract, just as each account, lives at a separate kind of locations. And now each contract also lives at a separate location. So there's never like a situation where one account has multiple addresses. Well, except for
it has the compressed. That's right. the risk
Yeah,
for.
except for the
Oh,
compressed.
so you meant that in the context of the compressed addresses, Micah. Sorry.
Yeah.
Okay, yeah, but then that's maybe so basically, like, is there anything then before we move to compressed addresses? I mean, Alex had a point here to kind of try and separate that. Is there anything like for the
I'm
pure
satisfied.
kind of short long?
Seems reasonable to me. I see no problem with it.
Okay, and then I assume what we talked last time about as well, but like maybe ways to make the existing ECDSA compatible with that, and indicating which one to use or something like that. I assume that should also be a separate discussion then, similar to how we talk about compressed separately. I take that as yes. So
I don't understand the question. What's the
well,
short version?
just if we have for context, last time we talked about how while we probably will have to have a new kind of EC Recover 2 or modify the existing EC Recover if indeed it turns out that you can just kind of like put optionally give in extra input data or something like, but at least that there will have to be a new version of EC Recover for long addresses, right, for the native world, but for situations where you have to be backward compatible with existing contracts that use the existing EC Recover, we were thinking ideally you don't want to just break compatibility with long addresses. So ideally, like once you call into EC Recover from an old address, you should basically just have a way to indicate which address to resolve to, like which period basically, like which version of the key to resolve to.
Yeah,
And
I
so
think
I think personas can solve that as well.
Yeah, but I think
Basically
we agreed on this last time, right? Like, I mean, I documented what we discussed there.
Right.
And I mean, just to recap, while it would be a nice hack to have like an optional extra input after the current 128 bytes in DC recover precompile, but unfortunately it doesn't have a length check so far. So there might be contracts which send extra input. So the better option is just not to touch the current precompile and introduce a new one. And for the new one, I suppose we just have to discuss this persona question in terms of the new transaction type and just apply the same rule to this EC recover. So whether we decide that it needs to include like an address or it just needs to include a prefix or whatever, I guess we can just make use of the same logic in both places.
Right. Although I would argue that the EC recover, the new one, should be like, it's more important to have that be forward compatible because we can't really easily change that afterwards. Whereas like a transaction type we could always change. So I would kind of like, I think it's more important for that design to be kind of more forward compatible. But yeah, I agree with you that we discussed it last time. Sorry, but I wasn't clear when I summarized that previously. Like I didn't actually want to recap that or talk about that part again. But there's this other aspect of EC recover that we didn't talk about last time, or like only briefly talked about last time. And this is how to make existing contracts compatible with existing contracts that use EC recover compatible with long addresses. And we briefly touched upon that last time as well, but that's a distinct question, right? Because like the new version of EC recover can only be used by new contracts, but old contracts already use a specific, the old EC recover, and they only send the existing input to that. So you can't kind of like modify that behavior. And so the question is, I
think personas solve that as well. Like we can choose almost the same system.
But it's not the same, right? Because sometimes you have situations where the sender of a transaction is not the same as the recovered. So but the question is, who is authorized to kind of indicate?
So a transaction can just contain a list of signed personas, basically. So you basically just attach a signature to the transaction that is signed by some private key and say, anytime this, like my address, like me, anytime this public key is used, this is the address I want returned for this whole transaction. And you can have like a list of 10 of these or 100 of these, so just like an access list sort of thing, where it's just attached on the end, and you can, it shows up when you do EC recover 2, whatever.
Well, yeah, I don't think it's necessary with EC recover too, but I agree that this seems the most feasible way of going forward, specifically to make EC recover for legacy contracts compatible with new long address signatures, basically.
Yeah, and I think we can, from a complexity standpoint, if we don't mind doing a trade-off in terms of transaction payload size versus complexity, we can use that same recovery list or whatever you want to call it for the primary transaction personas as well, if we wanted. It would bloat the size of the transactions, maybe not worth it, but it would decrease complexity because now you just basically have one place where you go, and this is anytime you do an EC recover, check here. If it's not there, then fall back to some reasonable default, which is probably legacy.
Well, EC recover is already, at least the current one, deviates from transactions because it doesn't have the check for it accepts both. No, well, that doesn't, that also is missing, but it also accepts both parties.
Oh, really?
Right. Although it is important to know that the signature you would put in the transaction itself to indicate how you want the EC recover behavior to work would be a different signature from the signature that then during transaction reaches EC recover. So the transaction on chain that reaches EC recover would follow the EC recover rules, whereas the signature in the transaction that indicates how EC recover should work, that would follow the transaction level signature rules.
I'm not sure how much we want to mix whatever is in a transaction and whether that influences how precompiled works, because we don't really have too much prior art for that. But also, just in terms for our discussion, we seem to have veered to EC recover again. I'm not sure we should discuss EC recover today. And maybe just, we haven't finished the other point and the compressed address, and there's a bunch of other stuff to discuss. So I'm not sure EC recover is like a priority for today. I think we really discussed it last time.
Yeah, we can move on. I just think that both my I kind of conceptualize it as being part of this persona conversation, because it's private keys should have a way within the transaction to indicate which of the on-chain accounts for the context of this transaction is the canonical one for them. But I feel like we have talked about it indeed now, and so we should move on. And I think next then would be the compressed addresses. Is that right? Can you summarize maybe the question there?
Can we have a compressed address as a persona? Can someone sign a transaction and say, for this transaction, use my compressed address?
Right. And important, of course, to note is that for the compressed address, there is not actually, at least in the happy case, there should never actually be something on chain at the compressed address location. So whereas for short and long addresses, you actually have a separate account living only at each of these locations. For a compressed address, that should only basically be a pointer that every time it's being used on chain resolves to the long address location, where then there actually the account lives, or the contract. Well, but if we're talking about transactions and the account, so there's nothing actually at the location of the compressed address. So this only ever becomes relevant once things reach the compressed address by accident, basically, because it wasn't yet in the transaction table and someone sent funds there, or things like that. So this is more like a fail-safe.
Big win. It gives us a really nice fail-safe if we allow people to operate as compressed addresses. We wouldn't want to encourage wallets to make this normal operating behavior, but it does give people a way to get out of situations that they might get themselves into, which worry us.
So the case where this happens, well, okay, one example case is the way the translation is populated. If you start a transaction from the long address side, so if you interact with from a long address context with like a legacy context, then the translation table is populated and you have the compressed one. But in the case of like a UX failure, somebody already has like the compressed version and creates a transaction not involving a long address, that this will just create the since the translation table doesn't contain it, it will just create a new account at that address. But I think this this obviously can happen for both cases, not just EOAs, but contracts. And by contract, one simple realistic example is like Gnosis Safe, right? And if you only make this possible for EOAs, then there's still this large surface for like contract wallets. And then why do we add this complexity if we are not solving it properly? So maybe that's one reason we shouldn't think about this.
Right.
Yeah,
also, maybe even more than just basically that we don't need it, or that it's kind of like just like a partial solution because it would only work for UAs. I think I'm not convinced, at least, that it wouldn't, that it's not just a complete non-starter for security reasons. Like, to me at least, it seems like once you allow this, then basically calling from such an address into a context that doesn't know whether it's been called into from like a legacy or a long address context. So say basically, basically to me that seems that they could make collisions even more problematic, in a sense. But yeah, I'm not sure yet. I haven't really thought the implications fully through. But I definitely agree that it looks weird that because it would only be a partial solution. So yeah, my intuitions very much say we shouldn't allow this, but I haven't yet formed like a very clear opinion.
Is there any way we can allow this same sort of persona for contracts? Like if the contract can do arbitrary transactions, I can imagine ways of like authorizing a thing. But if the contract, like for Gnosis Safe, for example, like I feel like we could solve that one specifically. But it is not nearly as clear to me how we'd solve it for contracts that do not have the ability to do arbitrary execution.
So I think the thing that makes this slightly confusing is the compressed address isn't really an address or a separate account. It's just a pointer that refers to, allows you to refer to long accounts in a legacy context. So like ideally what should be happening is that you have some operation that goes on in the long address world and it wants to call into the legacy world. So when it makes that call into the legacy world, all of the long addresses in the long address world get converted into legacy addresses by compressing them. And then the legacy world can like go about its business, never has to know anything about these long addresses existing. All it knows is there are these compressed addresses that refer to long addresses. And then at some point it calls back into the long address world, at which point all of the compressed addresses have all of the legacy addresses that are passed through have to be resolved. And the ones that are actually legacy addresses and don't appear in the translation table get turned into however the long address world stores legacy addresses, which is probably like a special epoch prefix or something. And all the ones that are compressed addresses get resolved through the translation table back into long addresses. And I think that's like the basic model we're going for. The problem is that like, how do we make sure that process can't go wrong somewhere? And we end up with like some long address, some compressed address, making it into the long address world and actually being treated as a special legacy address there and so on.
Right. I think that's so basically, there's a specific failure cases that I see are twofold. So one is that just like raw ether, if someone sends raw ether directly to the compressed address before it actually ever reaches the translation table. So say, I don't know, I don't know. We don't have to come up with a
Sure.
specific example,
Yeah.
but it seems very, very feasible that could happen. Also, like, especially, we have yet to talk about the exact nature of the translation table, but there are worlds in which we have like a completely ephemeral translation table, or at least like an expiring translation table, these kind of situations. So it could well be that sometimes even like once something was in a translation table, it might not be in the future or something. So that raw ethers reaches that, because if it ever is like a token or something, and it's in the legacy token contract, you should always be able to still call from your full long address, and then that just gets converted while it's being used inside the token contract. So it's only raw ether. The other one, big one that I see is just if someone on accident deploys old Solidity code at a long address, that basically where basically the Solidity code still truncates long addresses, right? Because there the opcodes would return the full long address, like for the caller or something, not the compressed version. And so they are basically the only way to ever kind of like recover funds or something that have been attributed to like compressed address or something, would be by kind of calling into it directly from the compressed address, because that will be able to pass through the code kind of unharmed. But both of these seem to be complete, like at least the latter one seems to be like an obvious, just like a fail-safe from a misuse of the blockchain, which to me just doesn't seem worth it, especially because it's like a special case solution just for EOAs. The first one kind of like could be worth it just in situations where we will go with ephemeral translation tables or something like that. But even there, we would ideally want to have a solution that also works with contracts, of course.
So for both of those, I feel like they can be solved independently. So for the first one, where you end up with ETH in a compressed address that has never been seen before, so you pre-send some ETH or whatever, I feel like we should be able to solve that one by just creating some new transaction type or something, or a precompile you can call, that will just allow you to just extract ETH from your compressed address. So you can basically say, hey, that's my compressed address. That ETH got there. It's a mistake. Please send it over to my actual thing. And that's something we can just verify with signatures, and it seems super simple. For the second one,
can I interrupt you there?
Go ahead.
Yeah, I was considering the same option because there was a proposal, an EIP proposal for this, recovering, some locked ether, and that proposal covered like one of these early Ethereum.js bugs and some other stuff. I'm not sure if you remember that proposal, but I mean this would kind of be, similar. And
yeah.
And I guess it doesn't necessarily need to be there from the beginning, but rather it could be considered if we see, like a growing amount of such cases happening on chain. So maybe it's possible to not have any such solution in place at the time of ASC is introduced, but rather have it on the back burner. And if we see that there's like a significant amount of such cases happening on chain, then maybe consider adding it.
Can I suggest like an even simpler solution? Just make the operation of adding something to the translation table, if this only works if we go in a world where the translation table is stored on chain. Also, it's like add the address to the translation table, take any ether that has been sent to the compressed address and move it to the long address that corresponds to it. And then like it's just impossible, because any ether that gets sent after the compressed address has been added to a translation table gets forwarded to the long address, and any ether that gets sent before gets moved when the compressed address is added to the table.
We actually have this in the specification, but it seems to be too much added complexity for the protocol.
Yeah, so I like that because I think it's very clean. I just worry a little bit about cost, just like it's expensive to do like state lookups every time, for example.
Also, again, this one thing that kind of like becomes much more complex once we add state expiry on top, just because it could well be that the the potential kind of original account that is attached to the compressed address might have already been expired. And so what that then means is basically you'd need to have exclusion witnesses every time you add an entry to the translation table. Or of course you could also have rules like you only kind of recover it in case it happens to be in the active state or things like that. But yeah, like basically with expiry, this becomes even more complicated. Also,
do we have the same problem for compressed address if we do like a precompile or a special transaction regarding the needing proof of in state expiry world? We need extra.
You mean if it's a special transaction type? That's nice because then it's up to the person doing this special transaction type to just provide all the proofs, and that's fine.
Oh, I see. It gives us a very
because
clear...
then it's exactly
Gotcha. Okay.
And then it's only actually used once there is an actual problem. So it's like only in a fraction of the cases does action have to be taken.
So I generally go ahead. Oh.
Yeah, but this only works. I mean, this first proposed solution only works for like end user accounts. So if the compressed address corresponds to contract, this special transaction will not help here.
No, I think we can make it so anyone can call this. It doesn't need to be permissioned. Like, is that correct? Like, we can just say, hey, if you notice that there's money in a compressed address and you can show me the uncompressed address, then we will move the money to the uncompressed address and we'll add it to the transaction map. And you provide witnesses. So as long as someone's paying for all that, then it doesn't matter who. Is that correct?
Well, kind of. So yes, we could do that. The problem here is, and that's by the way, the problem with all of these potential like compressed, uncompressed merge proposals is just the birthday attack issues, right? Where, for example, I could just grind out a long address and a short in the short address that where basically the compressed form of long address is the short address, and then I kind of create a new contract at the short address, and I convince people to send funds there. And then I later on just basically do this special transaction type where I show that I have the private key for the long address, and then just basically claim that the short address was only like a error that should never have existed and just has funds in there, and I claim the funds. So of course you could now have like special case rules where it has to also check that the code is 0 or whatever, right? But this is starting to really get very complicated. And so I just in general with a lot of these kind of merge issues, I just worry about the translation table then becoming an attack vector for birthday attacks.
I mean,
yeah,
we already
I kind of have
sorry, go ahead.
kind of have similar opinion that like we're kind of reproducing the issue we're currently trying to solve, which is the 80-bit security of the hashes. So there are kind of like other ways to actually exploit this lower security, and I think that was mentioned in multiple places already in the issues list. Maybe it would work. I mean, I can't kind of like resolve it in the terms of security, but it's kind of worrying sign of that.
I thought we agreed last meeting, maybe I'm misremembering, that counterfactual short addresses or short addresses that are used for counterfactuals are broken and you should not do it. And this is just another instance of that. But haven't we already agreed that?
Why is it counterfactual? In this case, it would be a contract, a smart contract that is actually deployed with a short address in legacy space, a contract that's actually deployed and people have sent funds to it. And now the funds can basically be merged out or like taken away.
Yes. So for that specifically, we can just check to make sure the code's not 0. Like just right before we send the fund, just make sure that there's not something there, just like this new EIP we just added is doing for.
Right, but then we're just kind of starting to create like more and more kind of narrow, like a rescue kind of operation for more and more narrow kind of use case.
I mean, like we need to do validation. We need to validate a number of things, but I don't feel like that should be a blocker for the solution, especially since we don't have, in my opinion, any better solution. Like this is the solution to beat for me right now is this. And that situation that you described doesn't prevent it, because we have an easy fix for it, which is just, a simple check to make sure that before the transfer happens, just make sure there's nothing living at that address. So it's got no nonce, it's got no code, and that's it. If someone has a better solution, that's simpler, I'm interested. But so far, I haven't heard anything that beats this.
That's a solution, though.
Why not?
Because you have to time this properly, right? So in the case you make like this wrong transaction first, so you interact with the contract without having it at translation table, and then somebody else interacts properly, and you don't have like an automatic merge or anything like that. Then you need to insert this like fixing transaction in between those two, because after that you won't be able to.
So, so basically saying, I feel like that sounds like a counterfactual problem, which may be misunderstanding. Like you're saying that you have an address that has no.
Or you meant the nonce and everything for the compressed address account, right?
Yeah. So when you submit this transaction or this call to precompile that says withdraw the ETH out of this address and move it into a corresponding long address, when you do that, it checks to make sure the nonce is 0 and the code is 0 at that address. If they're not, then the thing fails and it won't work. You can't withdraw the ETH. It stays there forever. If they are zeros, both, then it just lets you withdraw, and then you can delete that out of the state tree and add it to the translation map, and that compressed address will never be used again because it's now in the translation map.
I'm not convinced that this is needed at all, because this is still just solving a subset of the problem. And we are
right. So the other half of the problem, which I never got to because we got distracted. The other half of the solution, it feels like, was the contracts deployed with old Solidity code.
No, I actually meant something else.
Oh, okay. What's something else
then? Just tokens as an example, or anything else, because we only say that, with this discussion, we only say that we care about locked up Ether and nothing else. But, in the same note, you could also just assign tokens to like a compressed address. But I guess after the...
but it will always be, if you're in a legacy contract, then it will always be accessible by the long address, because it'll be compressed when it comes to receiving those tokens.
Well, but is it? That's what I'm just trying to figure out. So let's say you have a token deployed at a long address, right? So it's a new token that kind of like stores full 32-byte addresses and their mappings. But then someone accidentally within that sends to the compressed address some funds. And now, were you to withdraw to that kind of address something and it would actually send things there, that would resolve. But if it just kind of checks if the sender was authorized or something, then the sender will always return the full kind of long address. And so if you ever call, no matter if the kind of the unfortunate owner of this kind of
it depends on the
context, tokens,
right?
How so?
Isn't this like another big issue? So let's say you assign a token to the compressed address because you were in the legacy context.
Legacy token or modern token?
It has to be a modern token, otherwise it's not a problem. Yeah,
modern token.
Okay.
Then you need to deal with it on the legacy side. You cannot deal with it on the other side. Maybe with approvals, this approving like an old contract could work, but yeah, this sounds like a complex question.
So
I wanted to propose maybe that we write it down, this rescue transaction approach, because this seems to lack a lot of details that is difficult to catch on the call. But one more comment is, I think instead of just transferring the Ether, you actually need to execute the contract that is on the other side if it happens to be a contract. So there's also like code execution involved. But I think it's reasonable to like write it down and see how it looks on paper. Yeah, that's all I have.
Yeah, I think that sounds reasonable. And I like last kind of thoughts on that topic from my side is just that in some sense, especially like these questions around like let's say new token basically, and funds they are being misattributed to a compressed address or something like that. I think that's just a prime example for how we should just very clearly never we should never write code that has old contracts call into new ones, right? Because that direction just doesn't work. We are backward compatible where like new contracts can call into legacy code, but legacy contracts actually interacting with new tokens or things like that, it just doesn't work. Because then kind of they draw things out of call data that isn't aware of 32 bytes and all these kind of things.
Like Uniswap calls into any token that you throw at it, and we would expect Uniswap would not break suddenly with this introduction.
No, but it wouldn't break, but you could just it wouldn't actually it would break in a sense. Like you can't just take the existing legacy Uniswap and point it to a new kind of shiny new token and it wouldn't work. Like it wouldn't break Uniswap, but it would break that specific swap. That just wouldn't work because the two for the transfer would come from call data, and so it would be a compressed. So it would work in some scenarios, but then not in others, and it would just be a huge mess. So just don't do compatibility that way. Like don't start at a legacy and go into the new world.
So that feels like a deal breaker then, because we're back in the problem of if stuff doesn't work with new addresses, people will not create new addresses and we'll get zero adoption. Like if you can't use Uniswap with a new token, no tokens will be deployed with the new code. Like they'll all deploy old style because you need to if you want to work with Uniswap.
Okay, so then yes, so sorry, Peter.
Yeah, and I was going to say that like it's actually even worse than that because of DeFi composability. So for example, when you actually do a swap on Uniswap v3, what actually happens is you call into Uniswap, say I want to do a swap. The contract Uniswap sends you what you've bought, calls your callback, and then after the callback is completed, make sure that you actually paid for what you bought. And if you didn't pay, it reverts everything. So you can't, so like no one, it'd actually be quite difficult. You'd need quite a complicated, I think you could do it, but you'd need a special like shim just to even use Uniswap. And you could never take out a flash loan, which is like one of the most standard operations and is becoming an increasingly standard operation for people to do from legacy world. So I agree with Micah that it just completely breaks everything.
Okay, so then like, yeah. So what I'm taking from this is that I really want to spend some time over the next few days, and I'll basically just do a couple case studies, at least one, let's say like at least like a Uniswap. What would happen if basically you mix you just using the existing Uniswap code as an example, because it's reasonably kind of simple but also complex enough that it probably has problematic behavior in it, like a different combination of what if the one of the tokens is a new address, what if the call is a new address, what if the recipient is a new address, kind of like just different scenarios, just play it all out and see like when at which stages would addresses actually be compressed, where would they be truncated, which would basically, is there something that really looks like it's really hard to make forward compatible? I don't think we can rule that's not something to be synchronously done on the call, but I'll definitely spend some time just basically step by step going through like a very specific example. I think that would help at this point. Because I think we all agree, right, that basically I think we can make that address-based extension does not break the legacy world. We all agree that, maybe not fully, but right, but like basically I think we are kind of reasonably confident that address-based extension itself would kind of like, you could continue to live within the legacy world and everything would kind of work fine. You can live in the new world and everything would work kind of fine. And we hope that there's some compatibility between the two layers, but I feel like we all still don't really have like a really clear picture of what exactly works and what doesn't work and the current kind of ideas we have in the interoperability between those two address spaces. And that's I feel like what we really have to drill down, understand whether there are problems. And then looking at the clock, it's already kind of like closing in on our like 60-minute deadline. Did we want to talk a little bit today then as well about like the translation maps? I think, right, Alex, can you confirm that was the second thing you had on your that you mentioned earlier today? And if so, do we want to briefly start talking about that, or do we want to spend the last kind of 10 minutes or whatever, 5 minutes plus whatever we go over, continue the specific discussion?
It was, but I wasn't optimistic that we're gonna get there.
I mean, I'm fine basically discussing either. Just we can also stay on this topic if you feel like that makes sense. Or if I mean anyone here.
I think the only point we could do on like the access list or ephemeral translation map is just to give like an intro, but we would need to do that tomorrow or next time anyway. So maybe it's not worth doing anything with that today. Yeah, I think my takeaway is really just this token balance question is it's a bigger one again, and because of that, I'm not convinced that we need to think about like these partial solutions of like recovering ether, because why do we elevate that over any of these other risks? Just because it can be kind of solved? Is that the only reason we want to solve it?
Right, I think I'm with Alex here. It feels like this is over-optimizing for a very specific failure case that could turn out to be 1 out of 20, and then we basically have all this extra logic of special case handling for it. I definitely am open to that. Any kind of complete address space extension proposal in the end could end up having something like this in there if we really figure out that this is the one thing we can't otherwise solve. But I feel like at the current stage that we are at, I don't think it makes sense to have a provision in there specifically for sending from compressed addresses.
It would be helpful if someone has the time to just go and write out or add to the document maybe very tersely, like very succinctly, each of the example scenarios that we'd like to solve for. For example, someone sends ETH to a compressed address that has no code deployed to it, no nonce used. We need to handle that. Or contracts deployed as old Solidity code, and need to handle that. Or someone transfers a token to a compressed address that has no code or no nonce associated with it. Need to handle that. Just so that when we're having these conversations, we can just refer to like situation 7F instead of having to redescribe it every time. This is purely just for facilitating communication. Just
it's actually 1G.
Like, what was that?
It's actually as a number. It's 1G in the list.
Oh, do we already have those ones?
Well, I only added the heading that needs to be written.
Well, ignore me then if we already have them. Oh, I see what you're saying. You're saying you could add that to 1G.
Yeah, I guess before we close off, yeah, is there, I think you need to refresh the document in order to see the additions, but is there?
Yeah, that was my problem.
Is there any other point we should add? Maybe that would be a good thing to do, just to list these questions, and so that we have a record of them, and we can go through them next time. Do you think there's anything else which could be added?
I don't have anything specifically coming to mind immediately. If no one else has, like, basically the follow-up question that I was, yeah. So
I'm back. I'm back to bearish on address space extension. I flip every one of these calls. I flip back and forth. Bearish, bullish, bearish, bullish.
Yeah, but maybe this is also just like basically a sign that we have to get more concrete or something in the actual kind of like working out specifics, or like just looking at specific scenarios. Or I have to admit, for example, I haven't really looked a lot at the ASE test cases document yet, so I'll definitely kind of do that a bit more, and then also try to come up with some kind of scenarios that I find particularly interesting or problematic as well. But then for as Alex was kind of just now asking about like points to add for kind of discussion, and do we want to? I feel like because we still have this one topic left of the translation table, kind of the ephemeral one and the address lists, and maybe also kind of like the ideas around alternative to the ephemeral one, maybe the expiring one. So I feel like that's kind of like one natural kind of block of content still to be discussed. So how do people feel about the rhythm of these calls going forward? To me, it seems like there could be a scenario where we kind of do one more of these kind of relatively soon, so in the next days or something, and then maybe afterwards have maybe like a couple of days break or so to actually kind of look into these kind of scenarios individually or something. Or what's the, because I assume we can't just continue to have daily calls for the end of time. So I'm just wondering how people feel about that. But also, sorry if anyone wanted to, because I waited a little bit. No one mentioned any points for Alex to put up in a document. But if you have any, feel free to say that as well now.
I think we had a good streak and at these, and I would say it's not unrealistic if we want to have, maybe one or two more of these calls this week. Just judging based on how much time we spent on this list so far, I think we're lucky if we can finish like this the access list and ephemeral or expiring translation map topic in a single call. I think that is maybe possible, but maybe a tiny bit optimistic. And if we still want to talk about like this token balances stuff and the compressed addresses, I think that's we shouldn't mix those two topics into a single call, because then we're going to spend the whole call on compressed addresses again.
My preference is to not move on until we have some viable solution here, or until we at least agree that we don't need to solve this problem, one of the two. Because I don't want to waste work solving all the other problems of address space extension if we have some blocker. Like, for me, this currently is a blocker, and maybe with more conversation I can be convinced that it's okay that this will break, though I'll definitely need some hard convincing. But I just like, until that's fixed, like everything else doesn't matter. Like if we can't fix this, in my head right now, if we can't fix this problem, we cannot move forward with address space extension. And so there's no point in wasting time and effort and energy discussing all the other aspects of it, because this is a non-starter. That's my personal position.
Slightly different take there, in that I think the problem really is that we don't quite understand the exact nature of the blocker. Like, we always kind of end up talking about very specific examples where we think, oh yeah, no, this might not work, and then sometimes we kind of find a specific solution that works for that specific example. But I feel like we really need some time now. I think we all kind of like have like a really good grasp on with kind of exception of the topics we didn't yet talk about, right? So the kind of specifically the ephemeral translation app, but like on most other topics, we have a good kind of understanding of at least what the challenges are. But I feel like what we need is a little bit of time to just kind of figure out exactly what the nature of the problems are and which one of these could be blockers or something. I'm not sure if continued calls are the best format. So I agree with Alex's take that basically like one more or two more, depending on like if we get to the rest on one call, immediately, like basically as soon as possible kind of makes sense. But then afterwards, I feel like it's probably best to at least, I don't know, have a little bit of time in between. It doesn't have to be much. I don't know, maybe a week even just or something. But just so we can actually work out exactly what and if there are blockers and how those look like. But yeah, but it sounds like basically we'll definitely, like, it seems like everyone agrees at least that makes sense to at least have one more kind of scheduled call for the for whatever we kind of didn't yet get to.
So should we
Right.
try to do it tomorrow, Wednesday, Thursday, or Friday? Which day should we target?
Personally,
I'd rather do a day besides tomorrow. I
Right,
want to be
same.
available.
I'd have a week preference for Wednesday. I think I can make tomorrow work. I'm not quite sure if I'll be able to make it.
I have a weak preference for not Thursday.
So to simplify, tomorrow or Wednesday?
Both are fine with me around this time.
Sorry, Michael, what did you say?
I
Tomorrow?
think he said both are
Or
okay.
both days?
Both work for me at this time.
If we were able to just go like to another 30 minutes to the right, I think I'd be confident I could make tomorrow as well. But I'm not sure if that works with people.
30
So-
minutes later, you said?
Yes.
So like the time we started today or 30 minutes after?
No, unfortunately, it's at 30 minutes after. But
I mean, for me, that's fine.
I think Micah might be the one whom it's the least better.
Does anyone here go to the network research call, which I think is at that time?
Well, apparently we aren't.
Wait, no, I don't think that's right though. I think that would be the one immediately following. So basically, we could just not run over tomorrow.
So I was going to say that we do not do good at not running over. So yes, if we bumped it up half an hour, then we'd be back to back with the network research call. So if someone needed to make that, we'd have to cut exactly off at time.
Okay,
Well, I feel like
how about we do that, and that also limits us how much time. So we should then still discuss like this persona and compression stuff, and maybe we could target to finish it, earlier, not like 1 hour, and not get into the translation, like the access list and ephemeral stuff yet. How about that? And we target like 30-40 minutes tomorrow.
sounds good. And then we can have maybe one last call on Wednesday, potentially.
Just to be clear.
Mhm.
Sorry, go ahead.
No, but you go ahead.
Just to be clear, I don't have any ideas how to solve this. So if you guys have ideas that you want to bring to the table or try to convince me that this doesn't need to be solved, then the call will be valuable. When I'm going to show up to the call, though, with no idea. So hopefully one of you two will bring something to the table or someone else.
Wait, I thought the idea was to kind of try and have the call or calls tomorrow and or Wednesday be focused on whatever we didn't yet talk about. Basically, not continue the discussion of today.
Oh, I see. Yeah, we can, and I'll show up to that. Like I said, I find it uninteresting at this stage, but if that's what you guys want, I don't mind.
I feel like it just kind of makes sense because we have this document, like by the Epsilon team, we talked about kind of all the other aspects, just this one aspect, not yet. So I feel like it's just like a good conclusion of this series of calls. And then we can kind of take a step back, work through these kind of problems we saw in all these different topics, and then kind of reconvene maybe a week or two later or something and take it from there.
So I think it's worth to talk about access list because I think it might open some ideas for solutions. And I think we even mentioned some of these. So these are not complete solutions, but at least and you can additionally include some information in the transaction that prevents some cases we don't want to happen. So at least maybe on UX side, it can help with some of the key cases we have been discussed.
Yeah, I agree with Pavel that like just on the meta level here, that like basically having the full picture seems like a good idea to then talk about the figure out the problems, right? Because only if you have like a good idea of how the full system end to end would look like, can you really kind of determine if something ends up being a problem or not. So I feel like that's like the one piece that's missing. So yeah, to me it seems like a good idea to just have the call. And then I feel like we can if we just schedule something for 45 minutes, say tomorrow, like basically starting 30 minutes after today's session and ending 15 minutes after today's session, basically. So I mean, we're already 10 minutes after today's session, so I feel like basically, yeah, similar to today, then the end. Yeah, and then we see if we basically need one last on Wednesday, and then afterwards we'll take like a week or so of break, and everyone can like look into this individually. Does it sound like a good plan? If no one disagrees, I would just say we'll do this way. And yeah, and then is there anything left for today? Any short?
Sorry, are we
bring up?
Just to confirm, are we talking about the access list and ephemeral maps tomorrow, or?
Right. Oh, sorry. What was the alternative?
Well, I guess this compressed stuff to me. So maybe tomorrow is not a good time for that, but yeah, I feel like this compressed stuff, we would need to write down like all this, what has been said into like some concise paragraphs and think about it. So maybe we shouldn't try to do that. Yeah, I guess we can try the access list tomorrow, though that likely gonna take like the full hour.
All right. Wait. So then, did I misunderstand you earlier? Like, so you were proposing to continue talking about compressed addresses tomorrow. Was that your proposal? Like 5 minutes ago?
Yeah, I think I would continue, given we can write down, all of these, and because I think some of those questions were not fully clear to everyone.
Okay. Okay, so then change of plans. That's fine. But
no, whatever you suggested is fine with me. I think we spent like 15 minutes trying to figure out what call to have and what content we have for it. So.
No, but then now I feel like it makes sense. Like, okay, let me just basically, unless someone protests, we'll do it the following way. We'll have a 30-minute scheduled call tomorrow for just kind of formalizing the problems we discussed today. And then afterwards on Wednesday, we'll have one last 1 hour call to discuss ephemeral access lists, ephemeral translation map and the access list idea. And then afterwards, we hopefully take a good point to pause. Is that like anyone
that sounds good to me.
Okay, then let's do it this way. Awesome.
At the same time tomorrow, half an hour, or half an hour later?
No, like half an hour later would still work for me best. That's so,
Okay,
so that should still give you like a 30-minute buffer between the end of that call and the state call though. Okay, awesome. Thanks everyone.
Thank you. That was great. Talk to you tomorrow.
Bye.
Yeah.
Bye-bye.